Hi everyone, I'm Kui Chong Yi and I would like to present the system design project with the title Harvesting Solution of Fresh Fruit Bunches from the Oil Palm Tree. This project is the cooperation between UTM and also the Central Bee Plantation. Let me start with the introducing of my team. We are from System Design Section 6, Group 6. Our project is supervised by Dr. Amir Putra and team members are me, Kui Song Yi, Kamal Ho Chawan, Chia Sing Tong, Oi Jingping, and Sabir Ahmed. In this project, our customer is Santabi Plantation. The very first thing we need to do is to identify the customer needs. So this slide stated the needs statement from the customer. Device can ensure safety of workers, can reduce the number of loose fruit drops, can reduce time consumption need for harvesting FFB, can separate the front and FFB after cutting, can minimize the manpower, reduce the dependency of labor, and can improve the harvesting productivity. Next, I will talk about the current situation in the oil palm tree industry in the Santabi now. During the harvesting process, the first step is to cut the front and the FFB. So this manual cutting is not efficient and a lot of energy needed. Workers also exposed to the risk of the safety and ergonomics. After that, the FFB will drop on the ground. So this dropping of the FFB will cause the loose fruit spread on the ground and might hurt the FFB might hurt the workers. Some fruits might be damaged also. The third step is the collection of the FFB and the loose fruit. For the collection of the FFB, a lot of manpower is needed for the manual collection, and for the big clapper tractor, might have difficulties to enter some location which due to the muddy and soft soil. For the loose fruit collection, this manual collection of loose fruit will cause the wasting of time and the wasting of manpower. Lastly is the unload process. In this process, the collected FFB will be unloaded from the tractor into a bigger storage, which then be transferred to the other place. One of the statements regarding oil palm tree industry in the Parliament Malaysia is around 26,000 workers shortage in oil palm harvesting as of August 2021. Malaysia lost amount of 14 billion in 2021 due to the shortage of employment, which increased 56% from previous year. For the problem definition, traditional oil palm tree harvesting is inefficient and violates government policy to cut off foreign labor in the coming years. We would like to develop an oil palm tree harvesting mechanization technique that minimize manpower and improve the efficiency. For the design brief, we are going to design an oil palm harvesting device which focusing on cutting mechanism and collection of FFB. The device could be operated to cut the FFB and collect the FFB to the storage simultaneously through a ducting system to minimize the manpower time consumption process during the harvesting. The device must adhere to the safety guidelines and can be easily used. The device target only for the young oil palm tree. This is the objective tree for the device that we plan to design with four major categories, which are safety, cost, design and performance, and lastly the environment and convenience.
Our oil palm harvesting device will be able to cut and collect FFB from young oil palm tree with minimum manpower. This device aims to improve accuracy, efficiency, productivity, and also the safety of workers, where it will provide a short-term solution by using a semi-automated mechanism. The selection criteria of our device include performance, size, weight, material, cost, customer, environment, maintenance, product lifespan, competition, patents, ergonomics, and safety. In the functional structure, input is the action of the user and the output is to cut and auto-collect the FFB. First, the user will be driving the tractor to the desired tree. Power source will be switched on to allow the cutting chisel to vibrate. The user will adjust the chisel to the location of FFB and cut the front and FFB. Front will fall under the tree and the FFB will drop into the collecting duct and it will be directed to the storage. In the morphological chart, there are 5 design criteria, which are cutting, separator of front and FFB, duct, locking mechanism, and the power source. So each of us will brainstorm one idea for each criterion, and then they will later be used in the generation of individual concept design.
Next, I'm going to talk about concept design. Each of us has produced a concept design based on the morphological chart. For this first concept design, the ideas come from roller coaster, where the cutting device can be controlled more in a semicircle around the tree. For the second concept design, the idea comes from the automation engineering world. The main component of this design consists of chisel and sickle, smaller duct, larger duct, separator, clamping mechanism, and 2 motors. The sickle will be used to cut the front, while the chisel will be used to cut the FFB. For the third concept design, the concept was inspired by one of the mechanical harvester designed by Malaysia Palm Oil Board. The main component of this design consists of a grapple and a cutter, where it will be able to hold the FFB and cut the bunch stock of FFB. For the fourth concept design, the idea is very simple, which apply the use of the rod. For the last concept design, the duct applies ideas of aerodynamic shape, while a vibrator is used to cut the FFB. Next, I'm going to talk about the selection criteria of concept selection. The criteria include safety, ease of use, portability, weight, ergonomics, durability, efficiency, accuracy, reliability, manpower, size, environmental, maintenance, and cost. We have distributed the weightage based on the degree of importance of the selection criteria. Safety is the most important criteria and it ranks A, which is 0.13 out of 1. Ease of use and portability ranks B in terms of the importance. Then, it is followed by weight, ergonomic, manpower, durability, efficiency, and accuracy, which fall in rank C. Other than that, the rest of the criteria fall in rank D, E, F, and G respectively. Next, I'm going to talk about the screening metrics. We have chosen a design as our datum. Positive 1 means that it is better than datum. 0 means that it is equal to datum, and negative 1 means that it is worse than datum. From the screening metrics, we can see that concept 4 has the highest score, which is 3, followed by concept 2 and 3, and finally followed by concept 1 and 5. Next, from the scoring metrics, concept 4 has the highest score, which is 3.55. Hence, we have chosen concept 4 as our final concept design. So, improvement and modification are made based on the final concept, which is concept 4.
I'll be introducing our final design after numerous discussions. First, the worker needs to attach the device onto the buffalo tractor. The attachment mechanism is a U-shaped design with a bolt. From the detail view here, the yellow part will be the steel plate near the driver, and the U-shaped design are intended to fit just nicely onto the steel plate with a little clearance. There will be one T-shaped platform which will extend the rope further from the driver, and this is to ensure that the rope will not hinder the driver movement when driving the tractor. Next, moving up to the device, there will be one rotating swivel mechanism to allow the whole device to turn left and right like the motion of this fan. The mechanism will have one fixed plate mounted onto the fixed platform and one turning plate as shown in here. This will allow the worker to have more control to the cutting motion. After driving near to a young oil palm tree, the worker needs to work on the handle area in this device. This will allow the chisel to have an in and out motion in the Z direction from the safety box. The handle area is similar to the manual car handle, which there will be one T-shaped handle that is connected to the rope. The T-shaped rope will be slotted into this hollow compartment, which is a flip E alphabet shape. When the worker rotates the handle to the right hand side along the Z direction, it will allow the T-shape to slip into a freeway, which he could push the whole chisel rope upward in the same direction to position 3. On the other hand, the worker needs to rotate it back to the left hand side in order to fix the rope position in this direction. The movement of the chisel rope in Y direction is allowed by the pin mechanism as shown in here. When approaching lower FFB, the worker needs to pull the handle up in Y direction to access it. The handle area will be working with a spring down here, which its main function is to fix the rope in rest condition. When the worker is letting out their hand on the device, the spring will pull it back onto the default position. The bolt will act as a safety box when the handle is in position 1 so that the chisel will not cause any safety issue when the worker is not cutting the FFB. The chisel is vibrating in Z direction and it is powered by a motor. A crankshaft mechanism will turn the rotary motion of the motor into linear motion of the chisel in Z direction. When the chisel is blunt, the worker can just open up the casing and replace the chisel. So after the worker had adjusted the device into desired position and the handle is placed on position 3, the vibrating chisel will cause the FFB and the front to be cut. So after the front is cut, the front might fall onto the collecting duct lid. However, the big surface of the front will not cause the lid to open and the worker can just shake off the front by adjusting the device angle. Oppositely, when the FFB is cut, the FFB will exert a point force onto the lid and cause the lid to open. The lid will return back to the original position due to the compression force of this spring. The FFB will roll down to the storage following the duct shape. The detachable rigid duct will be made from aluminium material to reduce its weight. The end of duct does not lock with the storage to ease the collection of the FFB. This will be the whole cutting and collecting process of the FFB. Appropriate blend will be added to the sharp corner when considering the design perspective. Moving to a strength and weakness, the device will allow the company to harvest with minimum manpower. The device can reduce the harvesting cycle time by eliminating the collection process. It is an improvement based on the existing machine with no any other alteration needed to the tractor. The device is simple to operate and no specific training will be needed. Meanwhile, safety is our first consideration in the design process. However, our device will only limited to young oil palm tree where it does not have any adjustable height mechanism. It cannot reach different range of height, and there is also a possibility where the FFB will drop onto the ground instead of the duct.
The Sustainable Development Goals are a collection of 17 interlinked global goals designed to be a blueprint to achieve a better and more sustainable future for all. Our final concept is based on the 9th Sustainable Development Goal, that is industry, innovation and infrastructure. The crisis in the palm oil industry is mainly due to the government policy to limit the number of foreign workers as well as labor shortages due to pandemic. The tasks done by the laborers are also difficult. In order to reduce the crisis, more and more investment is required in the R&D field so that an efficient device can be innovated, thereby reducing dependency on labor force. Based on the strength analysis, we can conclude that the final concept aims to reduce the palm oil industry crisis, thereby forming a sustainable industrialization. This, in fact, will lead to decent work and economic growth of the country. The 10th Malaysian Technology Innovation and Economy Framework provides a systematic approach to transform Malaysia into a knowledge-intensive economy by design. It aims to generate shared economic prosperity across the diverse ecosystems in the country and shift Malaysia up the global innovation value chain. This formulation is based on the 10 science and technology drivers and the 10 socio-economic drivers. As our first concern was to design the mechanism, it can be said that under further improvement, the final design has a higher tendency to accomplish the socio-economic and science technology drivers metrics in terms of agriculture, forestry, and sensor technology. Thank you.